All right, welcome back to the discussion lessons. This is 1.4. 1.4 was on solving linear equations. So we've had a couple of questions on this section, so we'll go through those and talk about those. I think I'm going to break this up into two videos for this week, or for today's videos. I'm going to do one lesson in 1.4 and the other two sections 1.5 and 1.6 I'll do in a second video. So if you understood 1.4 and you're looking for 1.5 and 1.6, get out of here, go down to the next video. Otherwise, here we go. I had a question on number 4. Number 4 was solve for the variable. And then we had 2 times the quantity p plus 1 plus 1 equals negative 2p plus 2 times the quantity 2p plus 1 and then plus 1. Okay. Make sure I didn't go off my screen a little bit, stick my face in the camera. All right, we're good. So I'm going to just start by distributing, right? There's no fractions to get rid of, there's no decimals to worry about, so I'm just going to jump straight in and distribute. This 2 comes through, that becomes 2p plus 2. Plus that 1 more is equal to negative 2p. The 2 comes through and distributes to give me 4p plus 2 plus 1 more. Okay. When I combine all of my like terms, I've got just a 2 and a 1 on the left-hand side, so that leaves me with 2p plus 3 equals. On the right-hand side, I have negative 2 and a positive 4p, so that combines to be 2p plus 3. And you'll note that it's the exact same equation, right? I have 2p plus 3 equals 2p plus 3. If I try to continue and solve this, let's say I want to get my 2p's out of the right-hand side. That's gone. I want to get my 3's to the other side. That's gone, but so is that, and so is that. And I get 0 equals 0, which is true. I boil it down to something that's true regardless of what p is, right? And so if I get down to the point where I have the exact same thing on the left and the right, or I break it down to a 0 equals 0, then this is true always, and it doesn't matter what p-value you put in there, it's going to be true. And so this is, p can be anything. Which is to say it could be all real numbers. And so our solution then is that double barred R. If it's in this notation, if you're taking the test, you have to write it down. You could also write it in interval notation as negative infinity to infinity. Either way. All right. I was also asked about number 5. So number 5 says 1/5. I think it's the same. Solve for the variable. So 1/5 multiplied by x minus 2/3 equals 1/15. So we have to be careful here. This 1/5, when it gets distributed through, is going to multiply into this fraction as well. It's probably easiest to take and distribute this fraction before we start trying to get rid of the fractions. So that's what I'll do. I'll take this 1/5 and multiply it through. I have 1/5 times x, which is just 1/5 x. Multiplied by -2/3, I get -2 over 15 equals 1 over 15. And so it's nice and convenient then to say, well, my common denominator is 15, so I'm going to multiply everything by 15, or 15 over 1 if you want. How does that cancel stuff out? The 15 and the 5 cancel, leaving me with just a 3. The 15 and the 15 completely cancel here, and then the 15 and the 15 completely cancel here. Now the biggest mistake I see here is in the simplification here. This one's not too bad, it's just 3x. Minus, and this is all just a 2. But it's this one right here, when everything cancels, we're left with a 1. It doesn't disappear on us. It divides, it leaves 1s, and this simplifies down to a 1. So I should then be able to add 2 from both sides. And then I have 3x equals 3. And of course, dividing by 3, I have x equals 1. All right, let's take a look at number 7. I was asked to do 7 and 8. 7 and 8 are very similar, so I'm going to take a look at 7 and leave you to figure out 8. And again, if you still have questions on it afterwards, you can come talk to me, or you can do an office hour or something like that. But number 7 says, we're translating from English into algebra here, or into an algebraic expression. It says twice the sum of a number twice the sum of a number, and 4 is the same as. Five times the difference of the number. And 2. So it's one of those long statements. We want to turn it into math, right? So we're going to take this just a little bit by a little bit. The first thing I do is twice. Well, twice means to multiply something by 2, right? What am I multiplying by 2? A sum, right? So if I'm multiplying a sum by 2, I'm going to throw that sum in parentheses so that that whole sum then gets multiplied by 2. What are the components of the sum? Well, a number, x, and 4. So this expression right here is the sum, or sorry, it's twice the sum of a number and 4. Is the same as means equals. This whole thing right here is just equals. And then down here, 5 times, well, that means I have 5 multiplied by what? A difference. So I'll put that difference in parentheses, 5 multiplied by the difference of that number and 2. Right? So in the end, my expression is this. 2 times x plus 4 equals 5 times x minus 2. And I just have to solve this. So I'll start, distribute, that gives me 2x plus 8 equals 5x minus 10. Right. I'm going to push my x's to the left by subtracting, so I got minus 2x on both sides. Since my x's are going to the right, plus 10 to get it to the left. That gives me a 3x on the right-hand side, and 18 on the left-hand side. Okay. And so if I divide each side by 3, right, then I end up with 6. Again, once I get to this point, the question is very easy. It's creating this equation that most students have difficulty with. All right, that was number 7. I was also asked about 9. Let's take a look at 9. It says the quotient of a number in 3 is added to 2, resulting in 8. So again, we have to create the expression here, and we'll start bit by bit, just like we did before. The quotient means something divided, right? The quotient of a number and 3. That's the quotient of a number, I don't know, a number, x, and 3. Is added to, right? It's maybe tempting to say, oh, there's the word is, and that means equals, but no, we have to also consider that we're speaking English, and is not always translating over to an equation, right? This is added to, and so I add that to 2. And the result, this result right here is my equals, that equals 8. And so a lot of us would say, all right, the first step is to eliminate your fractions. I say don't worry about that here because it's easy just to subtract 2. You get that x over 3 on the left-hand side equals 6. But if I just multiply now by 3, I am done. And x equals 18. Let's look at number 10. 10 says solve for x, so I get x over x minus 3 equals 4. Okay. So I want to clear my fraction, so I'm going to multiply by the denominator, and that denominator is this x minus 3 expression. So I will multiply both sides by x minus 3. X minus 3 there, x minus 3 there. The x minus 3 cancels over here, leaving me with just an x. The 4 is going to distribute on the right-hand side to give me 4x minus 12. It's easy just to take my x's to the left, so I'll take minus 4x, That leaves me with a negative 3x on the left-hand side equaling negative 12 on the right. And if I divide each side by negative 3, I get x equals positive, because the negatives cancel out, and then 12 divided by 3 is 4. I was asked to do 11 as well. 11 is a similar process to this, but there's 2 of them, so I'll leave that one to you. If you have problems with 11 after this, feel free to contact me and we can work through it. All right, thank you, and I'll see you in the next video for 1.5 and 1.6.